In this video, we're going to look at the graphs of linear equations of the form y equals mx plus c. Linear equation, just like this one, y equals 2x plus 1. Here, m is 2, and c plus c is 1. C is 1. So we're going to plot the graph of this equation, and in order to do this, we need a table of values. We need a table of values that gives us the coordinates of every point on the graph of this equation. The points will then be joined up to give the line that represents the graph of this equation. So what does a table of values involve? It contains corresponding x and y values. And what does that mean? Okay, say I just choose x values ranging from -8 to 8. So I'm using an interval of 2. Interval of 2 means each value increases by a unit of 2 as I go from left to right. If I start from the smallest number to the largest number. So I'm starting with -8 and increasing by an interval of 2 for each consecutive x value. So this row, the bottom row, this row here, contains the x value. So I have -8, -6, -4, -2, 0, 2, 4, 6, 8. Now, in order to determine corresponding y values to each x value, one has to use the equation whose graph is being plotted. This equation is y equals 2x plus 1. What this equation is saying is that for any x value, the corresponding y value is obtained by multiplying that x value by 2 and then adding 1 to what you get. So let's take x equals -8. When x is -8, the corresponding y value is given by y equals 2 times -8 plus 1. So that gives y equals -16 plus 1, which is -15. When x is, let's try another one, when x is 4, the corresponding y value is given by 2 times 4 plus 1, which is 2 times 4, 8 plus 1, 9. So I'm just going to fill in the ones we've shown. So when x is -8, y is -15. When x is 4, y is 9. And if I do so for the other values, I get this table here. So all we did was replace x in the equation with its value to determine the corresponding y value. Now what I'm telling you is that each of these data points in the table, so each column here, contains the x and y coordinates of a point on the graph. This is another point on the graph, this is another point on our graph, this is another point, this is another point, and so on. X and y values. The bottom row represents x values, the top row represents y values. If you pick each column, picking a point, and each column contains corresponding x and y values. And these values are the coordinates of points on the graph. So in order to plot the graph, you plot these points. So the first thing we need is a calibrated pair of axes. The x-axis has to be calibrated such that it contains values that at least range from -8 to 8. And the y-axis has to be calibrated such that it contains all these y values. So from -15 to 17, we must be able to see these points on our axis. So that's what we're going to do next. In order to plot these data points, the x-axis and y-axis need to be calibrated appropriately. The x-axis needs to be calibrated such that the smallest x value and the largest x value appear somewhere on the axis. They don't necessarily have to be labeled, but we must be able to point out where x is -8 and where x is 8. Similarly, for the y-axis, we need to be able to point out the smallest y value and the largest y value on the axis. So it needs to fit in. So we need to make sure the calibration contains the smallest y and x values basically, and you see what I mean shortly. So I'm choosing an interval of 2 for the calibration of my x-axis. Now starting with 0, move to 2, 4, 6, 8, -4, -6, -8. As you can see, we have the smallest x value, -8, and the largest x value, 8. With regards to the y-axis, I'm going to use a different interval just because of the space limitation. I'm going to use an interval of 4. As you know, as you go upwards, y values increase. So by the interval, so 0 plus 4 is 4. 4 plus 4, our interval is 8. 8 plus 4, which is our interval, is 12. 12 plus 4, 16. 16 plus 4 is 20. And as you go downwards, y values decrease by the interval. You subtract the interval from a number. So 0 minus 4 gives -4. -4 minus 4 gives -8, and so on. So I have -12 here, I have -16, I have -20. As you can see, I can tell you that -15 lies somewhere between -12 and -16, somewhere here. So by the way, just to make it clear, this minus 4 refers to this point, minus 8 refers to this point, minus 12 refers to this point. So I should really write it right next to it, but I have my reasons for doing it this way. So I think let's just make it clearer. There's space limitations here, but if I put minus, I'll use a different color. So we have minus 4 as this point here, minus 8, minus 12, minus 16, minus 20. So we can say that the smallest y value, which is minus 15, will lie somewhere between minus 12 and minus 15. So we know it's somewhere on this graph. The largest y value, 17, lies somewhere between 16 and 20. Smallest x value, we can clearly see it here. The largest x value, 8, we can clearly see it here. So I could have gone up and even had 10 and minus 10. The only key thing is just all the y values and x values. We should be able to point out the y and x values on the graph, which we can now. So now we can plot the points. So I'm going to use a different color. I'm going to use maybe red or just some other, yeah, maybe red. So the first point, so I'm going to call each of these columns points. The x value is minus 8. So we have an x value of minus 8 and a y value of minus 15. So x is minus 8 and we go somewhere. X is minus 8 and minus 15. Minus 15 is somewhere here. So this is minus 8 and minus 15 lies somewhere between minus 12 and 16. If you with your graph paper, you actually pinpoint accurately where minus 15 lies. I am giving you a sketch, so we just know that minus 15 lies somewhere here. When you're doing this properly, you'll be actually pinpointing your points on your graph paper. So minus 15 is somewhere here and minus 8 is somewhere here. So our point is here. This is point. I'm going to call this point A. Actually, let's use a different color. I'm going to call this point A. Point A. Call this point B. Call this point C. Call this D. Call this E, F, G, H, I. So each column represents a point. So this is point A. Here, this is point A. The next point B, x coordinate of minus 6 and y coordinate of minus 11. So minus 6 is here. Minus 11 lies somewhere between minus 8 and minus 12. So that's somewhere here. So minus 6 and minus 11 meet somewhere here. So this is point B. Next point C has an x coordinate of minus 4 and a y coordinate of minus 7. So you locate minus 4 on the x-axis for the x coordinate. Locate minus 7 on the y-axis, which is somewhere between minus 4 and minus 8. And we know that they meet somewhere here. So this is just revision on graph plotting because you've done this in junior secondary. So this is point C. Similarly, for the next point, minus 3 and minus 6, the next point D has an x coordinate of minus 2. So I'm going to locate minus 2 on the x-axis and a y coordinate of minus 3. So this is a minus 3. Minus 3, which is somewhere between 0 and minus 4. So they meet somewhere here. Unfortunately, that crosses with the 2. But let's continue. Next point, point E, has an x coordinate of 0, y coordinate of 1, which is somewhere here. So 0, x coordinate, y coordinate of 1, they meet somewhere here. Point F has an x coordinate of 2 and y coordinate of 5. 5 is somewhere here. So this is our point, and this is our point F. This is point E here. Point G, so that's just 4 as an x coordinate and 9, which is somewhere here, as the y coordinate. So that's G. H, 6 and 13, which is somewhere here. And I, 8 and 17. So we have all these points, A, B, C, D, E, F, G. And when you join them up, you get a straight line. As you can see, obviously this is a sketch, so it's just going to be barely straight. This video assumes you've had some experience with graph plotting in your junior secondary school. So this is just a quick revision. As you can see, the plot of the equation y equals to x plus 1 is a straight line. Now, you will find that all linear equations, so all equations of the form y equals mx plus c, have plots that are straight lines. So you need to remember this, because you know what you're getting before you even start plotting. You know that while I'm plotting my graph, I should get a straight line. So let's say you were plotting, and instead of point B being here, say point B, you accidentally pinpointed point B as being here. And when joining up your graph, you have something like A, B, C, you have something like this. Now this will look odd, and you will know that you're clearly wrong because you should expect to get a straight line. So you need to recheck that point. So it's very useful to know that the graphs of linear equations of the form y equals mx plus c are straight lines. Here's another linear equation. The equation y equals minus 3x plus 1. C is 1 in this case, and m is minus 3 in this case. It's a linear equation. And we should expect that the plot of this equation will be a straight line, because all linear equations, when plotted, give straight lines. But we need a table of values. We need to generate the values that will be plotted. So we need to generate the coordinates of the points that will be plotted. Each column in this table of values represents a point. One row contains the x coordinate, the other row contains the y coordinate. It's very easy to generate these values because one just has to choose an x value range. Sometimes you'll be given an x value range to use, but in this case, for demonstration, I'm just going to choose one. I'm choosing one from minus 8 to 8. So when x is minus 8, using the equation, I can determine that the corresponding y value will be minus 3 times minus 8 plus 1, which is 24 plus 1, which is 25. I'll just pick another one. When x is, so then just fill in the table. I'm using minus 8 to 8 with an interval of 2 again. When x is, let's say, 0. When x is 0, what is y? What's the corresponding value of y? Well, y is minus 3 times 0, which is 0, plus 1. So that's 0 plus 1, which is 1. So I'm just going to fill in the table with the values I calculated. So when x is minus 8, I've determined that the corresponding y value will be 25. When x is 0, the corresponding y value is 1. Now, as you can see in the table just below, I've already filled in all the other data points. So looking at the table that's already been filled, so this is the table of values for the equation y equals minus 3x plus 1. The first row contains y values. The second row contains x values. Initially, an x value range was chosen, and the corresponding y value to each x value was determined. Each column here, I'm circling, represents a point. So I'm going to call this point A. I'm going to call this point B. This is going to be point C, and so on. So point D, E, F, G, H, I. So that's an E. It's an E. So now we're going to plot this point really quickly. First point has an x coordinate of minus 8. So actually, we need to make sure, just even before plotting the points, we need to make sure that the x-axis is calibrated so that it contains the smallest x value and the largest x value, because when it does that, when it does this, all the x values will be represented. Same thing for the y-axis. It needs to be calibrated such that it contains the largest y value, which is 25, and the smallest y value, in this case, which is minus 23. So I'm going to use an interval of, let's see, 1, 2, 3, 4, 5, 6. I'm going to use an interval of 2. 2, 4, 6, 8. Minus 2, minus 4, minus 6, minus 8. For the y-axis, I'm going to use an interval of, let's see, 4, 6, 8, 12, 16, 20. I'm going to use an interval of 5. 5, 10, 15, 20, 25. Here, minus 5. Let me use a different color, just so it doesn't get mixed up with the 2 here. Minus 10, minus 15, minus 20, minus 25. As you can see, the largest x value, 25, can be pinpointed on the y-axis. The smallest y value, which is minus 23, can be pinpointed because it's going to be somewhere between minus 20 and minus 25. The smallest x value, minus 8, we can pinpoint. The largest x value, 8, we can pinpoint as well. So now we can proceed to plot the point. So point A is a point with an x coordinate of minus 8 and y coordinate of 25. So it's going to be somewhere here. That's point A. Point B, x coordinate of minus 6 y coordinate of 19. 19 is just before 20 here. So point B is going to be somewhere here. Point C, x coordinate of -4 and y coordinates of 13. 13 is somewhere here between 10 and 15. So we're going to have something like this. Point D, -2 and 7. So -2, 7 is somewhere here. It's going to be here. So let me use an X, in fact, a cross to mark the points. Point E, 0 and 1. So 0 and 1 is somewhere here. So just marking that. Point F, 2 and -5. 2 and -5. So it's somewhere here. Point G, 4 and -11. 4 and -11. Point H, 6 and -17. 6 and -17 is somewhere here. Point I, 8 and -23. So, as you can see, if I join up all these points, I'm getting a straight line. And if you do so on graph paper where you've actually plotted everything accurately, remember this is just a sketch, a rough sketch for demonstration. If you join these points up, in reality, you'll get a straight line. And you expect a straight line because we're plotting a linear equation. Now, if one of the points, say, in fact, I'm going to say you accidentally pinpointed that point somewhere else and this point somewhere else. So let's say instead of -4 and 13, you accidentally did -4 and, I don't know, some other value like 20 something, and you put that here. And instead of 4 and -11, which was here, you did 4 and 5. Just for some reason you made that mistake. If you try to join these points up, A, B, you do not have a straight line anymore. You have some weird shape. This is what you have. So you know you're wrong. If you get this, you know you're wrong. You've made a mistake. And a lot of people make mistakes while pinpointing the points on a graph, especially when they're doing this for the first time. So you need to be careful. That's why it's very useful to know that when you have a linear equation, you're going to expect a straight line. You're going to expect a straight line. So there you go. So this line in red, which if you plotted neatly and accurately, you get a perfectly straight line, is the graph of y equals -3x plus 1. This equation that we're plotting. And this is the equation whose this table of values belongs to this equation. And the table of values just contains corresponding x and y values. So for an x value, it gives you the y value that causes those two to satisfy the equation. And each of these columns represents data points that you plot. One row here just contains x values, which we just chose an x value range. Sometimes in questions you'll be told the x value range to use. So all you have to do is just pick each x value and determine the corresponding y value using the equation, and then just pick up the points and plot them on graph paper. Now we're going to look at how to plot the graphs of quadratic equations. The technique is the same as that for plotting linear equations. It's the same. Now, quadratic equations are equations of the form y equals ax squared plus bx plus c. In this case, we have y equals x squared plus 0, x plus 0. So b in this case, the coefficient of x is 0. C in this case, coefficient of, well, the constant term is 0. Coefficient of x squared here is 1, so a is 1. This is a quadratic equation. It's of this form. Oh yeah, I forgot to say, where a is not 0. We're going to plot the equation y equals x squared. I told you that when you have linear equations, your plot needs to be a straight line, otherwise you made a mistake. For quadratic equations, the result of your plot must be a parabola, and that's a shape of this form, like an N in a way, or more like a hill, or an N, or an upside down, or a U. So it's a U or an upside down U, or a U and an N. You need to get a shape like this, otherwise you're wrong. So let's just focus now on just plotting. We're going to assume we didn't know what to expect. We're plotting a graph of y equals x squared. I'm going to pick a range of x values, -5 to 3. I'm going to use an interval of 1. So when I start from the smallest value, to get to the next value, I add 1, -4. I add 1 again to get to the next one, and so on. So -2, -1, 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. So you just keep adding 1. That's our interval. I just chose that randomly. Now, we're going to find the corresponding y value to each of these x values. When x is -5, so let's do that. When x is -5, according to this equation, the corresponding y value is given by minus 5 squared. That's 25. I'll take another one. When x is 1, y is equal to 1 squared, according to this equation. Y is equal to 1. 1 times 1 is 1. So let's just fill that in. When x is minus 5, y is 25. When x is 1, y is 1. And as you can see, I filled in the corresponding y values for the other x values here in this table. So let's just move to that table. So you can try at home to fill in these gaps yourself to see if they match with this. But it's a very simple process. So we're going to move on. Now we have our graph. We have our axis, and we need to make sure that the x-axis is calibrated such that we can pinpoint the smallest x value, and in this case, the largest x value. For the y-axis, we need to make sure that the largest y value is pinpointed on the graph, can be pinpointed on the graph, and that the smallest y value, in this case 0, can be pinpointed. So we need to be able to have, y values that are ranging from at least 0 to 25, and x values that range from minus 5 to 3. So let's calibrate the x-axis. This time I'm going to use an interval of 1, 0, let's use black, 0, 1, 2, 3, 4, 5. I'm just going to stop there. Minus 1, minus 2, minus 3, minus 4, minus 5. So the x-axis has an interval of 1. As you can see, the smallest x value, minus 5, can be pinpointed. The largest x value, which is 3, can be pinpointed as well. So let's move on to calibration of the y-axis. The smallest y value is 0. That's here. Remember, the 0 here represents the 0 for the x-axis as well as the 0 for the y-axis. So we need to be able to go up to 25. And this is just given my limitation. Now, if you're doing this on a big piece of graph paper, you can use any interval you want. Your graph can be as big as you want it to be. All you just need to do is make sure you can contain all these values. The x-axis must contain all the x values. The y-axis must contain all the y values. So you can actually plot this table of values. Okay, so we need to go as high as 25. So I'm going to use an interval of 5. 5, 10, 15, 20, 25. Now, I could decide to continue and label the y-axis, but there's no need for that because all the y values here are positive. So I'm just not going to bother with that. So now we're going to plot each point. Remember, each of these are points. So let's plot each point. The first one has an x coordinate of minus 5 and a y coordinate of 25. Minus 5, minus 5 to 25. So that's here, somewhere here. So this is 1 point. Minus 4 and 16. So x coordinate of minus 4, y coordinate of 16. Minus 4 and 16 is somewhere here, which you locate on your accurate plot when you do this at home with your graph paper. Minus 3 and 9. Minus 3 for the x value. And 9, which is just somewhere just before 10. Minus 2 and 4. Minus 2 and 4 just somewhere here. So we have a point there. Minus 1 and 1. Minus 1 and 1, which is somewhere here. Minus 1 and 1 on the y-axis, somewhere there. 0 and 0, which is the origin, the center point. 0, 0, x value of 0, y value of 0. Next point, 1, 1. So 1 is here and 1 will be somewhere here. So the x coordinate value 1 is here. And the y coordinate value 1 will be somewhere here. So it's going to be somewhere here. 2 and 4, x coordinate value of 2, y coordinate value of 4. So 2 and 4. 3 and 9, 3 and 9 somewhere here. So this is our graph so far. Observe what shape we get when we join the point up. So this is a rough sketch. Remember, you're going to do a neater one at home on your graph paper. You can see we're getting this sort of U shape. And remember, I told you when you plot a quadratic graph, you're either going to get a shape like this or a shape like this. And when I say a shape like this, it doesn't mean you have to get this complete shape. You can just get a portion of it, but you just know you're getting something that's a portion of this or the whole thing. So you can get this shape or maybe just this part or just this top part. Here we have a quadratic graph, and this is the plot of y equals x squared. So you can label this blue line as the plot of the equation y equals x squared. And that's all. It's that easy. The only issues you may have is in choosing an x value range or choosing a y value range and the interval to use for your calibration. But with practice, it'll come. You just need to choose ranges and intervals that allow you to contain all the values. And in terms of your range, sometimes you'll be given the range of x values to use, and in other cases you're gonna have to choose yours. But just make sure you choose one that allows you to show as much of the straight line or as much of the curve in this case as possible. Practice makes perfect in that kind of thing. We're going to try another quadratic graph.